Alright, so in this video we're going to be looking at the boolean data type. The boolean is actually the kind of data type that you work with when you want to know whether something is true or false. So it's very useful, and essentially there's several different kind of functions that we can work with it. So far we've seen two data types. We've seen numbers, which are real numbers, we've seen strings, and now we get to see booleans. Okay? So one thing you might notice is that, well, we can do equals, let's say 3 and 4. If I run this, it gives me back a false. Okay. Other languages actually can represent 0 as a false. For instance, C, that language represents 0 as false. This language, the only way you can represent a false is actually the keyword false. Okay. This is pretty important, especially when you're doing some kind of evaluation. And then we can replace this equal with a greater than, and this is going to run a false because obviously 3 is less than 4, it's not greater than 4. And obviously you have your other host of comparative operators over here. If you're going to be comparing strings, they will produce a predicate. For instance, if I do ABC and DEF, then this won't work because it's expecting two numbers. So if I try to do this, it's going to expect a real. But what I can do is do string greater than. And this is going to work because we discussed it over here that this function actually exists. Over here there's a less than, but we can obviously have a greater than. And this should return false because ABC comes before DEF. So there we go. Okay? So you have to make sure that when you're comparing data, you're doing it with the right sort of predicate. Okay? So we have those kinds of predicates to compare our data values. Now let's look at the special and, or, and not keywords. To do this, we're actually going to define a function. So define valid div, numerator, denominator. Let's just go, numerator and denominator. And we can say, well, I'm going to be, first, I need an and. I want to make sure that the numerator and the denominator are actually integers, because I don't want to be dividing by, actually we might as well just treat them as numbers. So number, numerator, number, denominator, and we should also check if the denominator is 0 or not. So if I do equal 0 to 10, this makes sure that 1, they're both numbers, and that the denominator is not equal to 0. So if I run this, I don't get any problems. Now let's actually do valid div. Let's say 3 and 4. This should return a true. Produce a true. Valid div. Let's try dividing happy by 0. Okay? If I do this, this returns, oops, I need a not here, because we don't want the denominator to be 0, right? So if I do not put the not, if the denominator is equal to 0, then it's going to produce a true, and then it'll work. But since I don't want it to be 0, I need to make sure that this is a not. So anyways, let's just run this again. So this produces a true, and this produces a false. And why does this produce a false? Well, first off, it goes, well, is the numerator a number? It says no. Okay. Is the denominator a number? It says, well, yes, it is. But the denominator is equal to 0, and that's a problem. So for those two reasons, the function returns a false. Let's look a little bit more closely, though, because there's something interesting that happens. If you notice, these two parts are highlighted, which means that the function never actually ran this part of the code. And the reason is because as soon as it realized that the number, that the numerator is not actually a number, it just produced the value. Because this function AND doesn't need to evaluate the rest of these arguments to know that this is all going to return a false. Because after all, as long as there's at least one false inside of the entire AND statement, the entire statement is going to be returned as, it's going to produce a false value. Okay, and then that's why when we ran this, we saw that number denominator and not equal to 0 denominator didn't even run, simply because we already short-circuited over here. The same thing happens, this is not going to make sense, but if we do an OR, you'll notice if this runs, the only part that doesn't run is the not. And what happens with an OR is, as long as there's at least one true value inside of the entire statement, you can consider that the OR statement will produce a true value. So it didn't see that the string happy was a number, so it went on to the next one. Is the denominator a number? Yes, it is. So this produced a true, and it went perfect. That's all I need. And then the entire OR statement evaluates to a true. And it doesn't need to evaluate what this is, simply because it knows no matter what this is, I'm going to be producing a true value, simply because the denominator is a number. Okay? Obviously, for this function, an AND makes the most sense. But this is exactly how this function, the AND and OR work. They have lazy evaluation, and they do this simply because it's the best way to do it. You preserve cycles, it's very efficient. Okay, why do extra work when you don't need to do it? So that's what that is. The key takeaway, make sure that you remember, is that you can use these to compare number data types, and you have to use their equivalents in the string to compare two strings. And finally, for the AND, OR, and NOT, they can take any number of arguments, but what needs to happen is they will have lazy evaluation. Interestingly, if you just give an AND, it's going to evaluate to false. Oops. This will evaluate to false. Okay. Perhaps it does expect more than, a few arguments. If I true. Guess true. That's interesting, because when you're evaluating the AND, it actually goes all the way down to make sure that everything's fine. Anyways, that is all for Boolean values. So hopefully you understand a little bit more about them. I'll see you in the next one.